Hello everyone. In this tutorial, let's see how we can use Quartus and Vivado to simulate some basic logic gates. So on pen and paper, everything looks right, but there is a need for simulation to simulate any circuit that we design to ensure it works as expected before we actually build the hardware. So in this tutorial, we're not building any circuits, we're just making a quick introduction to the tools Quartus and Vivado. So let's get started. When we first launch Quartus, this is how it will look. So let's click the first step. We can click a new project wizard under project and then click next. You can click the three dots here to choose where you want to save it. I'm going to save it in my C drive under Intel in this path. So I'm going to create a new folder. I'm going to call it logic gates. And then I'm going to select this folder. So now what's the name of this project? I'm going to also call it logic gates. So click next. So we can select template or empty project. So select empty project, click next. We don't want to add any files, so click next. Here we don't need to change anything, click next. So here we're gonna use VHDL and Questa Intel FPGA is good for me, so click next. So here it'll give you the summary. So everything looks right, the path, the name of the project, and so on. So click finish. And then click yes to continue. So just give it a few seconds to create the project. So this is it, the project is created. Under Project Navigator, you can click Hierarchy or switch to Files. I recommend you always keep it in Files so you can see the files inside your project folder. Also on the top here, you can see the path where you're working in which directory. So this is the directory we're working in. So now we need some place to design our circuit. So we can click File, New, and then you can select the block diagram schematic file. So this will give you an area where you can pull logic gates and design any circuit. So this is it. This is how it will look like. So this is your go-to, the symbol tool where you can pull some gates. So you can search for them under logic. So AND2 is an AND gate with 2 inputs, AND3 with 3 inputs, and so forth. So let's pull some AND gate with 2 inputs. Keep it simple for this project or tutorial. So you can place it anywhere on the canvas. And then you can click the escape button on your keyboard if you don't need more than one. Now let's pull some OR gates. You can type OR 2. So this is an OR gate with 2 inputs. Click OK. And then let's place it underneath the AND gate. Escape. Let's get some NAND gate. We can type NAND 2. It'll give you a NAND gate with 2 inputs. Let's also get an inverter or NOT gate. So you can click NOT. This will give you a NOT gate. Let's place it here. So now we need some input ports. So in this here, you can select the drop down, you can pull inputs and outputs. So let's have some inputs. Let me place it here. Since each gate, some of the AND, OR, and an NAND, it has 2 inputs, so we need 2 input ports. You can click the escape now. We can align them. So now let's give them some names. So you can double click on the pin name and just like type capital A. And then for this one, we can right click. We can do the same thing, but I'm going to show you both methods. So you can double click until it's highlighted, or you can right click, go to properties, and delete this, and just like give it any name you want. I'm going to give it capital B. Okay. So now we can connect them directly. We can connect this to this input, but I'm going to do it another way. So now this is directly connected to this input. We can do the same thing for B and then branch it and connect it to all of the other gates. But let me show you the other way. It's better, more efficient, especially when you have like big circuit designs. So let's create a branch here. For every input, you can left click and drag. And of course, you can click the control, zoom in, zoom out. You can click this here to pan around. So this is good for now. Now to connect this to input A, you can simply right click properties and give it the same name, A. So that means they are connected. And then similarly, we can connect this to input B, right click properties, give it the same name as capital B, it'll be connected. So let's repeat the same for the other gates. So we want to connect this to input A, and we want to connect this to input B. Similarly, for this NAND gate, we want to connect this to input A. We want to connect this to input B. And then for the inverter or NOT gate, let's connect it to input A. So that's it. So now we need some output ports. We want to see when we simulate, we need some outputs. So from the drop down here, you can select some outputs. So that's it. We need an output for each gate. So now we can connect them. We can connect this to this one. Now let's give them some unique names. So for this one, let's call it Y underscore AND. So we know when we simulate, it's easier to visualize. This one Y underscore OR. We know this is an output from the OR gate. Y underscore NAND. This is an output from the NAND gate. Y underscore NOT. This is an output from the NOT gate. Now this is it. Let's save it. So file, save as. In the same folder, we want to save it as PDF. So let's keep the same name. We don't want to add this file to the project, but I'm going to keep it for now. So you can uncheck this. We don't add it to the files, to the project files. If we keep it checked, we'll add it to the files. Let me add it for now because I'm going to show you later that we don't need it. So now we see this logic gates.pdf in the files. But since we want some VHD files, so we want to create a VHD file. So to do this, we go to File, Create Update, Create HDL. So, and then we select VHDL. And then we click OK. So this is successfully created. 0 errors, 0 warning. Now we can close the compilation report. And then now we can go ahead and open this VHD file. So we can click Open or go to File, Open. And then this is our VHD file, Logic Gates VHD. Open. And then now we need to add it to the files of the project. So to do this, under Project, we can click on Add File to Project. So now we add it. We don't want to have both files in the project folder, so we want to get rid of the PDF, and we're gonna be working with VHD file, so we can get rid of the PDF. So to remove the PDF file, we can left click on it to select it, go to Project, Add, Remove Files, and then we can select it again in here and then remove. Apply and OK. Now the file is removed. So this is it. Now let's compile this VHD file. So you can click on this, Start Analysis and Synthesis, or another way to get this, you can go to Processing, Start, and then Start Analysis and Synthesis. I'm gonna do it from here. And then you'll wait until analysis and synthesis complete 100%, and you want to make sure you have no errors. Let's give it a few seconds, depending on your machine. So now the summary, and then as we see here, 0 errors, 1 warning. We can ignore this warning here about the processors, number of processors. So 0 errors, this is good. So let's close this, the compilation report. So the VHD has mainly 3 parts. So part 1 is the library definition, including work where your project will be stored. Next, the entity definition, which is a wrapper that defines the inputs and outputs to the design component. As we can see, we have A, B, and we have some outputs. And part 3 is the architecture, which defines what your entity does. So next, we need to generate some test bench, which we will use to run the simulation. So to do this, we can have a Quartus create the test bench for us. So we can go to Processing, hover over Start, and then the second from bottom, Start Testbench Template Writer. So we can click on it, and then it's working on generating it. It generated with 0 errors, so this is good. Now we can close this, and then we can go ahead and open this testbench file. So we can click on Open, and then now you see like it created a couple more folders. So you can find the test bench in simulation, Questa, and then this is VHD file. Open. Let's save it as VHD because we're working with VHD. This is what we will need to in Vivado to run the simulation. So we can do file, save as. We'll just click the VHD file type. So let's also call it, give it a little bit different name. Let's call it _TB, which stands for Testbench. It's fine. We can add this file to the project. So save, and then we can see it's added to the project. So this is our test bench. Everything is good. If you see here like buffer, you can change it to std_logic. And then in this loop here, this will always execute. As you see here, this comment code executes for every event on sensitivity list. So here we can create some logic to run the simulation. So we know for two inputs, gates, we have four possible combinations. We saw that in the truth tables. For two inputs, we have 0, 0, 0, 1, 1, 0, and 1, 1. So we want to run the simulation for every single combination and see if the AND gate will output 1 when both inputs are 1. Otherwise, it will output 0. The OR gate, when either input is 1, it will output 1, and so on. So let's do this. To give an A a value of 0, we can type A, this symbol here, equal, quotation mark, 0, semicolon. Also same thing for B. So B less than equal, and then let's give it 0 for this line, semicolon. And then we can do wait for a couple nanoseconds. Let's do 100 nanoseconds. And then now we need, let's copy paste this. This is the 0, 0. Now let's do 0, 1. When A is 0 and B is 1, we'll wait 100 nanoseconds. So let's paste it another time. So now we're gonna do 0. We did 0, 0, 0, 1. Now we're gonna do 1, 0. Wait for 100 nanoseconds. And then lastly, we wanna see when both are 1, when A is 1 and B is 1. So now we can save this file. So this is it. So now we're gonna execute, let's just align them. So we're gonna execute these four combinations for A0, A0 and B0, 0, 1, 1, 0, and 1, 1. So now let's compile to make sure we didn't make any errors. So start analysis, give it a few seconds until it completes to 100%, and let's make sure there are no errors. Okay, there are some errors obviously in what we typed, so let's go back to our code and see what we did. So what we did wrong, actually, we need 4. So wait 400 nanoseconds. Save. And then let's compile again. So wait until it completes 100%, hopefully without errors. Okay, so this is good. It compiled successfully with 0 errors. So now we can close this and we are done with the Quartus. So we have our test bench and we have our VHD file. So now we can go to Vivado and run this simulation. So when you launch Vivado, this is how it will look like depending on the version you're using. So you can click Create Project, Next. You can choose where you want to save your project. I'm going to save it in the same location, in the C drive. So I'm going to create a new folder here. I'm going to call it Logic Gates Vivado. So this is my folder. So I'm going to select it. And then I'm going to call my project, same thing, Logic Gates. And then I click Next. RTL is fine. Next. We don't want to add any files now. We'll do it later. So click Next, Next, Next. And then here it says you don't have any source file, which is fine. So click Finish. Let it update. And then that's it. Now under simulation sim1, you can right click, add sources, add or create simulation sources. So you click next, and then now you need to add some files. So this is the files we created in this folder, logic gates. We're gonna add our VHD file, click OK, and then we're gonna add the Testbench file. So click again on add files, under simulation, Questa, and this is why we saved it as VHD. So this is our Testbench. So click finish, and then let it finish updating and make sure there are no errors. If you expand sim_1, you see both files, the Testbench and the VHD file. So now you can go to settings, under simulation, and then under simulation tab, default it's 1000 nanoseconds. I think 800 will be enough. So click OK. And now under simulation, you can click on run and add run simulation, run behavioral simulation. And give it a few seconds until it finishes. So this is it. So now to view the results, you can, let's just like adjust this window a little bit. So this is good. Now you can right click and click full view to see all the waveforms. So this is good. So A and B are our inputs and those are the outputs. So let's start with the AND gate. We know for an AND gate, when both inputs are 1, the output should be 1. So if we look between 0 and 100 nanosecond, A is 0 and B is 0. So the output Y is 0. 400 to 200, A is 0, B is 1. The output is 0. From 200 to 300, A is 1, B is 0. The output is 0. From 300 to 400, where we have A is 1, B is 1, and the output is 1. The NAND gate is the opposite to the AND gate, and we see this clearly in simulation. So from here to here, 0 to 300 nanosecond, you see the NAND gate output is 1, the AND is 0, and then from 300 to 400, the output of the NAND gate is 0, but the output of the AND gate is 1. For the inverter, so we chose A is the input to the NOT gate. So as we see, when A is 0, the output of the NOT gate is 1. When A is 1, the output of the NOT gate is 0. And now for the OR gate, from 0 to 100, A is 0 and B is 0, so the output of the OR gate is 0. From 100 to 200, A is 0, B is 1, so the output of the OR gate is 1. Similarly here, the output is 1 because A is 1 and B is 0. And then from 300 to 400, A is 1 and B is 1. The output of the OR gate is 1. So this is how we can simulate using Quartus and Vivado. I hope this was helpful. Thanks for watching.
Enjoyed this video? Subscribe to the Computer Engineering Notebook for more tutorials on computer architecture, embedded systems, and hardware design. And hit the bell to catch the next one.